Wastewater math quiz number 2. Pretty sure there's a poop joke in there somewhere. Things you need for this quiz: a calculator and a formula sheet. As always, I do not own any of the questions or material presented in this video. They've all been sourced off the open internet. This video is for educational purposes. Hopefully it helps you learn. Let's get into the questions. Question 1. A small treatment plant has decided to accept septic waste. The plant currently receives about 0.8 mgd of flow with an influent ammonia concentration of 35 milligrams per liter. If the treatment plant accepts 3 loads of septic waste per day at 3,000 gallons each, what will the new ammonia concentration be? Assume an ammonia concentration of 450 milligrams per liter. A. 28.4 milligrams per liter. B. 30.2 milligrams per liter. C. 39.6 milligrams per liter. Or D. 31.0 milligrams per liter. Question number 2. The MLSS concentration is 2,750 milligrams per liter. After 30 minutes of settling, the settled sludge reading is 320 milliliters. What is the SVI in milliliters per gram? A. 112 milliliters per gram. B. 120 milliliters per gram. C. 116 milliliters per gram. Or D. 125 milliliters per gram. Question 3. What is the hydraulic digestion time for a 49.5 foot diameter digester with a level of 9.2 feet and sludge flow of 8,230 gallons per day? A. 16 days. B. 12 days. C. 18 days. Or D. 20 days. Question 4. Determine the amount of chemical oxygen demand entering an aeration tank in milligrams per liter if the influent flow is 2.66 million gallons a day and the COD loading is 3,055 pounds per day. A. 124 milligrams per liter. B. 138 milligrams per liter. C. 142 milligrams per liter. Or D. 150 milligrams per liter. Question 5. What is the biochemical oxygen demand loading on a trickling filter in pounds per day if the influent flow into the trickling filter is 1,250 gallons per minute and the influent BOD5 is 215 milligrams per liter? A. 3,100 pounds per day of BOD. B. 3,350 pounds per day BOD. C. 3,492 pounds per day BOD. Or D. 3,228 pounds per day of BOD. All right, our answer is question 1 was C, question 2 is C, question 3 was A, question 4 is B, and question 5 is D. All right, now let's solve those questions step by step. Question 1 was: a small treatment plant has decided to accept septic waste. The plant currently receives about 0.8 mgd of flow with an influent ammonia concentration of 35 milligrams per liter. If the treatment plant accepts 3 loads of septic waste per day at 3,000 gallons each, what will the new ammonia concentration be? Assume an ammonia concentration of 450 milligrams per liter. First, let's pull our known and unknowns out of our word problem. So what we know is there's a flow of 0.8 mgd. The influent ammonia is 35 milligrams per liter. The septic waste is 3,000 gallons, and you're going to do that 3 times. And the waste ammonia is 450 milligrams per liter. What we're looking for is the new ammonia concentration. So the formula you're going to use to solve this is blending. Blending is C1 times V1 plus C2 times V2, which is equal to C3 times V3. So C is going to be your concentration, V is going to be your volume. On this slide, we have rewritten the equation to see what we're looking for. So what we're looking for is the new ammonia concentration, so C3. To find that, you divide out the volume 3. So to solve this, we're going to do C1 times V1 plus C2 times V2 divided by V3. It's going to give you C3. So the concentration and volume of 1 plus the concentration and volume of 2, we're going to divide that by the total volume, which we're going to get by adding the volume of 1 and the volume of 2. And this is going to give us our ending concentration of 3. All right, to start off, we're going to plug in the things that we already know. So your concentration of 1, so C1 was ammonia of 35 milligrams per liter. V1, or the volume for 1, was the zero point 0.8 million gallons a day of flow. And then we know the concentration of the septic waste. So C2 was 450 milligrams per liter. Now we know that the waste is going to be 3,000 gallons. There's going to be 3 loads. We're going to have to convert that into million gallons a day. So we'll do that on the next slide. All right, so you have 3,000 gallons times 3 loads times 1 mgd over a million gallons, so that the gallons will cancel out. So 3,000 times 3 divided by a million. And when you do the math, you're left with 0.009 million gallons a day. So we can plug in our 0.009 million gallons a day for your V2. Now V3 is going to be equal to V1 plus V2, so 0.8 million gallons a day plus 0.009 million gallons a day. You add those together and you get an answer of 0.809 million gallons a day. So let's solve everything in the brackets. 35 milligrams per liter times 0.8 mgd, and then 450 milligrams per liter times 0.009 mgd. When you do the math in the brackets, you get 28 and 4.05. So now we're going to add those together. So 28 plus 4.05. And when you do your addition, you get 32.05. Now we're going to divide that by 0.809. When you do your division, you get an answer of 39.6. So the answer is C. Question 2 was, the MLSS concentration is 2,750 milligrams per liter. After 30 minutes of settling, the settled sludge reading is 320 milliliters. What is the SVI in milliliters per gram? All right, first let's start by pulling the known and unknown out of our question. So what you know is the MLSS is 2,750 milligrams per liter. The settled is 320 milliliters. And what we're looking for is the SVI in milliliters per gram. So the formula for this is sludge volume index milliliters per gram is equal to SSV milliliters per liter times 1,000 milligrams per gram divided by the MLSS milligrams per liter. So we can just plug everything into our formula. So you have 320 milliliters per liter times 1,000 milligrams per gram divided by 2,750 milligrams per liter. So let's do the multiplication on the top first. And after you multiply that, you get 320,000 milliliters per liter per milligram per gram. So then we're going to divide that by 2,750 milligrams per liter. And your milligrams are going to cancel out. And your liters are going to cancel out. And the answer is 116.36 milliliters per gram. And the closest answer is C, 116 milliliters per gram. Question 3. What is the hydraulic digestion time for a 49.5 foot diameter digester with a level of 9.2 feet and a sludge flow of 8,230 gallons per day? Let's pull our known and our unknowns out. What you know is the diameter is 49.5 feet, your level is 9.2 feet, and your flow is 8,230 gallons per day. What you need is your digestion time. So the closest formula on the Florida formula sheet is sludge age days is equal to solids inventory in pounds divided by the influent solids added pounds per day. We're just going to change the units of measurement. So digestion time in days is equal to the number of gallons divided by the influent sludge flow in gallons per day. So first we need to find our volume. So we're given the diameter of our digester. So it's 0.785 times diameter squared times the height. So we plug those in. So it's 0.785 times 49.5 feet squared, so times itself, times 9.2 feet. And that gives you 17,695.7 cubic feet. We need gallons. Remember, there's 7.48 gallons in a cubic foot. And you set this up so what you want to cancel goes on the bottom. It's underneath, it's dead. Cubic feet will cancel out. So you have 17,695.7 times 7.48. And that gives you 132,363.9 gallons. And we plug it into our formula. So we have 132,363.9 gallons divided by 8,230 gallons per day. Your gallons will cancel out, leaving you with days. And when you do your division, you get 16.08, or the closest answer is A, 16 days. Question 4 was, determine the amount of chemical oxygen demand entering an aeration tank in milligrams per liter if the influent flow is 2.66 mgd and the COD loading is 3,055 pounds per day. Let's start by pulling the known and unknowns out. So what we know is the influent flow is 2.66 mgd, the COD loading is 3,055 pounds per day, and what we're looking for is the COD in milligrams per liter. Again, we can figure out what formula to use by looking for what we don't know. This is going to be a pounds formula, the Davison pie chart. We're just going to rearrange it to solve for the milligrams per liter. So to do that, you have the dosage milligrams per liter is equal to the feed rate pounds per day divided by the flow mgd times 8.34 pounds per gallon. So we have 3,055 pounds per day divided by the 2.66 mgd times 8.34 pounds per gallon. So do the multiplication on the bottom first. We do that, you get 22.19. So now we can divide 3,055 pounds by 22.19. And the answer is 137.67, or our closest answer is B, 138 milligrams per liter. Question 5 was, what is the biochemical oxygen demand, BOD5, loading on a trickling filter in pounds per day if the influent flow into the trickling filter is 1,250 gallons per minute and the influent BOD is 215 milligrams per liter? So let's pull our known and unknowns out. So what you know is your flow was 1,250 gallons per minute, your influent BOD was 215 milligrams per liter, and we're looking for the BOD pounds per day. Hey look, it's another pounds formula. Feed rate pounds per day is equal to the dosage, or just milligrams per liter, times the flow million gallons a day, times 8.34 pounds per gallon. Alright, so we need to convert the 1,250 gallons per minute to million gallons. So we have this set up so everything cancels out. So you have 1,250 gallons per minute. The minute goes on bottom. We're going to multiply that by 1,440 minutes in a day, and the minutes will cancel out. We're going to multiply that by 1 mg over a million gallons. We're going to divide, and you get 1.8 mgd. Now we can plug everything into our formula and do our math. So 215 milligrams per liter times 1.8 mgd times 8.34 pounds per gallon. And the answer was 3,227.6. And the closest to that is D, 3,228 pounds per day of BOD. That's it. 5 quiz questions solved. Hopefully this helps you learn. Thanks.